Recording in progress.
Hey guys, this is Mr. D of DSS Review Center, and today I will be discussing polynomial functions, particularly graphing polynomial functions. Okay, so this is the polynomial function, the equation. As you see here, a polynomial function is a function, okay, with exponents in decreasing order, okay, from the highest exponent up to the constant number, where a sub 0, a sub 1, up to a sub n are real numbers, and a sub n should not be equal to 0. And n is non-negative integer. So the p is called the polynomial function in x of degree n. Okay, let's make it simple. A polynomial function of the form f of x equals mx plus b is called a linear function, and its graph is usually a straight line. A polynomial function of the form ax squared plus bx plus c is called a quadratic function. The graph of a quadratic function is a parabola. Okay, so for today, this is your goal. I can sketch the graph of a polynomial function. Make sure that before the end of this video, you can be able to sketch the graph of a polynomial function. And to graph a polynomial function, you may consider the procedure below. Okay, number one, write the polynomial function. Assign three consecutive integers as domain. Substitute the integers to the function to get the range. Plot each point on the Cartesian plane and connect the points to form the graph of a function. Okay, before we start with the graphing procedure, let us have here PX in real life. When you are asked to report the sales of a company for the first 5 months, it may not be practical to present the data this way. Okay? So your boss may be disappointed if you present it this way because it's very hard to see. When you are presenting, you need to inform the body what you are reporting. Okay? In that case, you better present it with a table because this can be clearly observed, or you may present it with the use of a graph. If I were your manager, I prefer the graphical method because I can clearly see the trends. I can already see the flow. Okay, I can already give my recommendations if I see your presentation this way. So that's why it is important for you to show the graph of a function. It is important for you to know, to determine, or to master the skills of graphing, because definitely in real life you may use it. Okay, so let's now proceed with our main goal for today, which is to sketch the graph of a polynomial function. And we have here three examples. So letter A is a linear function, letter B is a quadratic function, and letter C is a cubic function. So we will focus first, okay, on the linear function. So to be able to sketch this graph, we may use this procedure. Write the polynomial function. The polynomial function is 2x plus 5. Assign three consecutive integers as domain. And of course, to assign, I may use 1, 2, 3. I will not be using 1001, 1002, 1003. Okay, because it will be harder to sketch the graph. Okay, substitute the integers to the function to get the range. So what we're going to do here is the value of x will be substituted to the function, to the value of x here. So the x here will be replaced by 1. So we will have 2 times 1 plus 5, then If x is 1, the function is 7. Next, let's substitute 2. When we replace x by 2, we'll get 9. And when we replace x by 3, we'll get 11. So at this point, we have now 3 points. One is the first is 1, 7, 2, 9, and 3, 11. If we're to locate these points on the Cartesian plane, then we can see that this is 1, 7, this is 2, 9, and this is 3, 11. And that when you connect all the points, you have shown, you have sketched the graph of a linear function. So you are done with your goal number 1. Let's proceed to goal number 2. Okay, so we will be showing the graph of x squared minus 2. Okay, so following this procedure, we will have the polynomial function x squared minus 2. Now, should I use 1, 2, 3 once again? Yes, I may use it. I can also use 3, 5, 3, 4, 5, negative 1, negative 2, negative 3, okay? But I have a specific reason why I'll be using negative 1, 0, and 1. I will explain to you later, okay? So using these 3 consecutive integers, I will replace x by negative 1, and I'll have negative 1 squared, which is 1, minus 2 is negative 1. So I have here negative 1. And then when I replace x by 0, I have 0 squared is 0, minus 2 is negative 2. And if I replace x by 1, I have here again negative 1. And with this, I have 3 points, negative 1 and 1, 0, negative 2, 1, and negative 1. Okay, so if I plot these points on the Cartesian plane, I have negative 1, negative 1, 1, negative 1, and 0, negative 2. Okay, as you notice here, if I connect the points, I form a parabola. Okay, now you know why I use negative 1, 0, and 1. Because it's actually the whole, it shows the complete graph. If I start with 0, 1, 2, or 1, 2, 3, as you notice here, 1, 2, 3, I can only show the right side of the parabola. So it is also important for me to show the vertex and at least 1 point to the left and 1 point to the right to show the flow of the graph. Okay, so last is a cubic function, x cubed plus 3x squared plus 2x. Again, we will be using the same formula, but this one is a little bit different with the first two. Okay, how? Let's see. Let's use the same process. Writing the polynomial function here, and then I will be using negative 2, negative 1, and 0. Again, I have a specific purpose for using these numbers. And then substitute. When I substitute negative 2, okay, look at the solution. I have here 0. When I substitute negative 1 and simplify, the result is 0. And when I substitute 0, obviously 0 cubed, 0. 0 squared, 0 times 3 is 0, 2 times 0 is 0. That's why I will get also 0. Now I have 3 given points here. Negative 2, 1, 0, negative 1, 0, 0, 0. Okay? Now, if I plot these points on the Cartesian plane, I will have these points. Okay? But here you can see already the trend because I graph it with the use of GeoGebra. But if we do it that manually, we cannot actually see the clear trend where this point will be going. Okay? So in that case, what are we going to do? So negative 2, negative 1, 0. If you have these points, okay, you may actually try a point be on the left side of negative 2. And what is that? So let's try negative 3. If I try negative 3, as you see here, it becomes negative 6. And negative 6 is really going this way, okay, to negative numbers. So I'm now sure that from negative 2, the graph will go this way. Okay? How about after 0? How would I know that the graph will shift, will goes up? Okay? So how can I know, how do I know? So from 0, okay, I may replace or I may substitute 1 because 1 is on the right side of the graph. So if I substitute 1, I will get 6. So it is very clear that 6 will go up. Okay? Now, how about in between negative 1 and negative 2? Okay? So I may try negative 1.5. But negative 1.5 is hard to substitute to this equation. So instead of negative 1.5, I will be using negative 3 over 2. When I substitute, okay, I can get 3 over 8. And 3 over 8 is before 4 over 8, which is 1 half. So it's before 1 half. Now I know that from negative 2, the graph will move up to 3 over 8 and goes down again to negative 1. So I am now sure that this is the flow of the graph. While in between negative 1 and 0, if I substitute negative 1 half, I will get negative 3 over 8. And negative 3 over 8 is almost negative 1 half. So I am now sure that from negative 1, it goes down and up again to 0. Okay, so it's now clear that the graph of this polynomial function is this one. Okay, that is negative 3 over 8, and that is 3 over 8. Okay, so once again, this is Mr. D of DSS Review Center, and for more videos, just subscribe. Muli, thank you and have